my name is Sebastian Deutsch, and
yeah, hi, I'm Stefan. We are both working for Non-Elements. So today we are going to think a little bit about animations in the web browser.
And how we can achieve them. We have several emerging technologies, as you heard in the talk before, of the new APIs. JavaScript APIs, what you can do is like you can use Canvas to draw things, you can have scalable vector graphics for vector animations, and you can use the new CSS3 transitions to do like DOM element movements. There are other low-level techniques like WebGL or 3D, which we don't cover in this talk, but they do exist, and if you have questions, you feel free to ask them after the talk. The company we're working, Non-Elements, got quite popular when we released an HTML canvas demo like 2 years ago. And it's funny because like we're a software company which has a strong focus on design, but we're a software company. It's like suddenly all people knew us for like, oh, you're the company with the dots. And we said, yeah, we're doing software. And like, no, you're the company with the dots. And now we accept it's like, yes, we're the company with the dots.
And we've gone HTML5, so
yeah.
And that's cool. So let's open the demo. No, that's not it. Praying to the Wi-Fi god.
Internets.
Well, it should. And we can skip it. Let's just go on with.
Okay.
Can you close it? Yeah.
Maybe it starts.
Yeah. So let me just do a quick recap of Canvas. I think so. Who of you have done some Canvas stuff? So who submitted something to JS1K to the competition? Only one of you guys. So. I mean, basically, that's just basic stuff. You have like a DOM element, a canvas tag in your HTML. And then in the JavaScript, so that's actually CoffeeScript because it looks way nicer on slides. You just get the element and get the 2D drawing context out of that. And then you just go apeshit. You can do like, you can draw rectangles, arbitrary paths. You can draw quadratic curves and stuff like that. I mean, you can build everything with Canvas. So let's do animations with Canvas. How does that work? So animations in Canvas, at first it's a little bit, I don't know, I was kind of surprised. So you have to do everything manually. You have like one big draw loop in which you clear the canvas, like you fill it with the background color, which actually is a very computing extensive operation because you have to fill so many pixels, at least on most Mac browsers, I think. Then you calculate positions of your objects on your canvas. So, oh shit, it's not working.
Maybe just take this demo, that should be working fine.
Oh, that's cool.
There's another Canvas demo, which is offline as well, on conferences. No, actually, nothing is working since.
Which one are we using? Let's check. It should work.
No, it's not learning. It's like.
Reopen it. Okay, let's try this again, and then we just continue with the slides. Oh, now it's working. Alas, it was the evil cable.
So what we're doing here, it's like when we go into the demo, we're gonna obtain the canvas here, as depicted here, and
oh yeah, sure. Let me do that. There it is. And increase the size a little bit, right? Can you read it?
Okay, can you read it? Okay. So what we're going to do is like we get the canvas, then we get a context, which is actually the instrument, the API, where we can like draw things. Then we're going to define interval handler, where we like call a function every 30th. Or what
70 times a second.
Yeah, 70 times a second. And we're going to clear the canvas with a fixed width and the fixed height, and then we're going to set the context like we have like some particles, we define some objects, and we fill them with a particular color, and then we're going to draw a circle. This is the arc function. Canvas does not have a native circle function, so we're going to draw it. And it looks like this, and we added some movement, so if you click your mouse, then they're going to move there, and all that computation where you want to move them, what do you want to do, you have to do it manually. You have to compute it by yourself.
Yeah, so basically, I just shortcut to because I wanted to show you, I think now that the internet is working, it would be pretty rad to show you the initial demo.
Machen wir einfach das auf IO/ und klick das an. Das ist die falsche URL. Ganz rechts.
Yeah, that one. There it is. So actually, that was our first experience with Canvas. You know, it's like getting data from Twitter, like tweets containing the word HTML5, and then we kind of visualize those on a black background and do these random kind of movements. And actually that became quite popular, which kind of made us go further into that direction, because it's quite a lot of fun to do animations using that stuff. So let's go back to the presentation. So there's another important thing if you do like drawing on the web. So what about interaction? So you cannot like bind click handlers to elements in the canvas, because there are no DOM elements in the canvas. You are drawing everything manually. So what you actually have to do is you get the XY position from click events, and then you have to calculate kind of which element has been clicked by yourself. So that's kind of tedious sometimes, but if you do it right, it should work just as well. And actually, there are libraries which simplify that task. So if you want to go into Canvas, I recommend checking those two out. So the cool thing about Canvas is it's very flexible. You can do pixel level manipulations. It's very fast for some things. And if you draw something, later on you can just export it to an image and store it. And it also got some drawbacks. Actually, it is resolution dependent, because you're always pushing pixel values. So unless you're using a framework where you kind of have a way to multiply values into a bigger or a smaller space, you might have a problem. But actually, if you scale up a canvas, you get this nice pixel retro effect. And I think, yeah.
We have some demos that you already seen. We have another one. Which I click here, which we implemented for a client who has to visualize communication between computer nodes. And we were like thinking in the first place if we do it with Canvas or if we do it with SVG. And the task for the client was like to create a visualization which can handle up to 5,000 nodes. And with SVG, it will be pretty slow. So we've chosen Canvas, which is slow as well, but it's acceptable. And we created that map where you can zoom in, zoom out, and you can see if a node is online, offline, you can click. And as Stefan said, like it was very tedious work to create all the event listeners and to do it manually.
Yeah, I mean, basically, what you've just seen is like hover effects. So you have to recalculate whether your mouse position is on top of some object in your canvas, and when you click, you have to do the same thing.
Okay. This is another demo. You can draw shapes with Canvas, like rectangles or circles, but you can draw images or whatever, bitmaps as well. And we created some nice control, which is not like when you see it, you would see, okay, this is Flash, but it's not Flash, it's Canvas. And you can click images as well, and you can highlight similar results, and they're going to be focused. And all these computations are done manually. This is a downside, but I think the performance is pretty good. It's pretty comparable what you can do with Flash right now. Okay, let's come to the second technique to graphics, which is scalable vector graphics. As we also mentioned, the problem is that Canvas is resolution dependent. So if you take your browser and you're going to zoom in, the images get very blurry. So with SVG, you don't have that problem. You have that, and if you're going to zoom in there, it does not get blurry at all because it's vectors. And so how do you do it? SVG is an XML substandard, and it's a language to define two-dimensional graphics in a declarative way. You can do as well filters, animations, or even sounds. And one of the cool things is that it is DOM-based. So this is an example how to draw a circle on a surface. You see the XML element for circle, the SVG container, and you see some attributes like CX, CY for center X, center Y, R stands for radius, you have a fill color and a stroke. Are you familiar with fill and strokes, what it is? Okay. This is a more complex example where we're going to define a gradient in the SVG definitions, and then we're going to draw an ellipse and animate the attributes in it. You can define the animations natively with it, but it's rather complicated to do it in XML. It does not feel very...
Yeah, I think it's tedious. It's like you want to say 2, and you say 1 + 1 - 1 + 1 - 1 + 1 to get to 2. It's like very much noise, very little information. So, yeah, I think you know that.
Yeah, this is a quote from the Nokogiri documentation, which is an XML parser, and it says, like, XML is like violence, but if it does not solve your problems, you're not using enough of it. Luckily, there's a very, very nice JavaScript library, which is called Raphael.js, and this is the point where JavaScript comes in. It abstracts the whole XML to nice JavaScript functions, where you just say circle or rectangle, and you can put as many objects as you want on a paper, which is the SVG equivalent to Canvas. And it has also some very cool animation functions, and it has also a VML fallback for the Internet Explorer. And it really works in the really filthy browsers, if you know what I mean. Interaction with SVG is pretty easy. You can use the browser's native capabilities because SVG is XML, and it lives in the DOM. You're going to add an ID to your XML elements, and you say get element by ID, and you add an event listener for click, for mouse over, or whatever, and you have basic interaction. This is pretty easy. So the pros for SVG is that it's resolution independent. Event handling is a piece of cake, and since it's XML, you can also spice it with ARIA attributes to make it accessible. But you can't do any pixel manipulation with this. If you want to display many objects, many pixels, or you want to transform something from color image to grayscale image, then SVG is not for you. Usually it's slower than Canvas. This really depends on the browser implementation, and it definitely needs Raphael for if you want to support all browsers. We used it in a client's work where the goal has to be to create something which works in most browsers, and almost the stuff you can see here, the pie chart is done. You can create some shares, and you can have some funding round for your startup. And
is it Raphael?
Yeah, actually it's done with Raphael.
gRaphael, right?
Yeah, it's a plugin on top of Raphael, gRaphael, where we have like very nice interactions. And even these little icons here are done with Raphael as well. So they scale very nice.
Yeah, it's pretty cool. So, so another example, we really like those dots.
Yeah, we're the company with the dots, so we like riding the wave.
We decided to stick with that. So, yeah. So, I think what kind of emerged as the most awesome way to do animations in the last year or so is CSS3. So, I don't know if you know this side. I mean, it has nothing to do with animations, but I think that's a lot of box shadow. Can you see the glow? So those rays are glowing. So if you're trying to do animations on this thing, so if you're basically those are all divs. Those are all divs with box shadow, and they are WebKit transformed into place. So if you animate them, no matter the browser, it doesn't work because it's so much not hardware accelerated, filter stuff going on. There's no way you can get above 1 FPS or something. So, yeah, so we've implemented the same dot thing again. And actually, it runs not that fast in Chrome.
Because Chrome is not hardware accelerated, but if you run it in Safari.
On iPhone, on the iPad.
Oh, you can run it in Safari here, but we're going to...
Oh, yeah.
Maybe this is what we're going to show you on the iPads. Like we implemented the whole 3-dot thing. We're going to release it after the talk on GitHub, so you can see the source code for yourself. And we implemented the first thing in Canvas, which is pretty slow on the iPad. It works, but it does not look so nice. We have a SVG version, which is slightly faster, but not that fast as well. And we have a hidden champion at that point. It's like a version with CSS transitions, and these are almost like run at full frame rate. So it's a very, very interesting thing to use and abuse CSS transitions to create animations.
So, quick recap again. So how do you do effects? How can you move elements and transform them? Oh, actually, that is supposed to say WebKit transform. Sorry. So, and the second thing, how do you do animations? Well, you use the transition or the animation attributes. So, just a very quick recap. You have like these 4 parameter value to set, where you say which value you want to animate for how long, given a timing function. So there's an extra slide for that in a second. And you can like set an initial delay. So if you want to delay a transition or an animation, you can do that. So, timing, yeah.
We dig a little into some timing functions. If you do animations, you can do, you have several possibilities to add a timing function. It's linear, ease in, ease out, and cubic Bezier function. And we try to explain it visually. It's like move the object from A to B in the same time with the same velocity. Easing means start with a higher velocity and was heißt bremsen?
Decelerate.
Decelerate in the end. Ease in is it decelerates in the beginning and then gets faster. Ease out is the same like ease. Ease in out is like having both deceleration in the beginning and the end. And cubic Bezier is the possibility to add your own spline function to have like a bounce or something. You can create very interesting stuff with this one.
Yeah, so basically you have four transform app operations you can push into most browsers. So you can translate stuff, which means moving it. You can scale it. You can rotate it. And there's this nice metrics attribute where you can basically, you can feed it your own metrics, which might be pre-calculated, which might come from a native iPhone client, so demo coming up. And what makes those CSS3 animations super useful? Well, we already said it. So the problem with Canvas and SVG is it's not hardware accelerated on most devices. I think by now IE9 is the only browser accelerating Canvas. Is that true? No? Which one as well? Mozilla? Yeah, 4. That's awesome. So, well, and of course, interaction is also native because you just animate DOM elements and old story.
So okay, on iOS it has superpowers, but on Android it's a little sad. It's like all the nice transitions you do on iPhone, which run like at full frame rate, they don't run at full frame rate on Android, sadly. And on non-WebKit it looks more like this. Yeah. Luckily, Firefox 4 implements transitions. Funny thing, if you do a translation of an object in Firefox 4, it's slower to do it with the transform properties, with the matrix and transitions, rather than set your own set interval and use margin top and margin left. But they implemented it and they're going to improve it, and one day it's going to be fast enough to do everything you want to do with this. Okay.
Yeah, so basically, to wrap it up a little, you have to decide which one you're going to use to solve your problem, and there is no best solution. But here's some advice. So you kind of, when you have to solve your problem, you think about, okay, does it run on mobile? Does it run on the desktop? So that's a vague rule of thumb. If you go mobile, you should go for CSS3 transitions and stuff like that, because that works really, really well. You also have, like, when an animation or a transition is finished, you get WebKit, you get DOM events being fired, so you can chain together animations. It's a bit limited at the moment, but it's working quite all right. And yeah, so first you look at the device, and then you look at the problem you're trying to solve. So you've seen the network map. If you have like a huge canvas with many nodes, you shouldn't put that into the DOM, you just draw it. So
if you wanted to run in all browsers, in the most browsers possible, you use SVG, but you have to keep an eye on performance. If you want your super mobile solution, then go with CSS transitions. If you know that your target audience is going to be iPhone users, iPad users, then go with CSS transitions.
So I'm trying to access the last demo on the iPad. So this is I'm going to access it here. Oh, by the way, that's a cool Canvas game, I think. Is it Canvas?
Yeah, it's Canvas. The game was just created out of curiosity what you can do with Canvas, and it also has sound.
Yeah, look, we're running away from IE6 trying to eat us.
Yeah. It is never. We have just one level finished because we had no time.
The first iteration was like, man, that's so awesome. Like, now make it super, super awesome, and then you know how project goes sometimes.
You have client work to do, and
so that was before IE9. We wouldn't have done that now. So yeah.
Okay.
All right. Thank you very much.
Any questions?
Not yet. Is it?
Not yet. The source for the game, or this game was created by some interns at 9elements. So the source is pretty undocumented, pretty buggy, and we always wanted to clean it up and then release it, but we do not have time until like mid-2011. And maybe we're going to release it for the sake of it and then fork it and clean it up.
Yeah.
Just release it and make this at the next World Game.
Okay.
All right. Thanks. Objective-C client running on here, capturing the gyroscope data. And it's connecting to a node, which is running on some server in Germany, I don't know where. And so the web client is connecting to the node via a WebSocket, and if I turn my iPhone like that, I get like, yeah, it's pretty red. It's not normalized, so if I hold it like this, it's fucked up, but I could like subtract the rotation value from some initial starting point. And you could also hook up WebGL to that, so this could be like a virtual kind of object you could turn and look at, which might be very interesting. So it's a little bit going into the augmented reality direction, I guess.